We are talking about wireless and wireless technology. And first, some words about my background and the background of my group. And then we come to the technology part, and then Marek will continue and show what you can do with that technology. I'm part of the 5.net group in Germany. 5.net is just another community, but we try to bring free and open wireless networks to the people, explaining how that works, developing technologies to make it work, and well, for different purposes. For example, internet access or intranet, it depends. Free and open for us means everybody can take part. It's open, there's no encryption, no registration whatsoever, everybody can take part. It's purely non-commercial. We just do it in our free time, and we do not benefit whatsoever by this network. It's purely community owned. We're just a big group of developers, wireless experts, or those who want to become one. And well, we do not censor anything. You can do whatever you want in our network or in your network. It's owned by everybody. So what we are trying to do is we try to build networks which can cope districts, villages, or even regions. All that via normal VLAN technology, because you can exchange then in this network data. You can do voice over IP, or you can share radio internet connection, which makes it much more cheaper for everybody, or community radio, or whatever you can imagine you can do with that network. As I said, we are doing that via VLAN technology. As you can imagine, normal VLAN technology can't do this. Normally you have managed networks, which means you have some kind of infrastructure, an access point, and then normal notebooks, and then you connect to that access point, and then you can connect to the internet or whatever. Or you have these so-called ad hoc networks, which means everybody joins the network, in a certain range can take part, and then you can do whatever you want. But all these technologies are too limited. We want to create networks which span regions or cities, and well, that's the goal. So we created another technology, which we call mesh networks, which works like this. Imagine you have three nodes, A, B, and C, where A can see B and B can see C, but A and C have no direct connection. And then you have some magic in your network, which tells A that C is there and can be reached over B. And then the data is sent to B and then reaches C. That is the idea of mesh networks. As you use intermediate nodes to connect a lot of nodes with one another. Well, when the network becomes bigger, it looks like this. So we have all these yellow dots are nodes, and the red circles are the range of the dot of these nodes, and then they connect to one another over this meshing technology. For example, today the network is quite flappy, and if we had used mesh network here, then one node, imagine that node can go down in the middle, and then the protocol will find a way around, network continues to flow. Well, in the end, the idea is that these networks grow and then organize themselves. So what is the purpose or what is the idea behind? We created software that is able to detect what nodes are there, what are the best ways to get these nodes, and to build this network. The advantage is that everybody can take part quite easily. You just need some cheap hardware, you put our software on it, and just switch it on, and then it will find its way through the network, all alone.
Is there a big time delay for the far ends of the network?
Again,
is there a time delay very big between a very long network like that?
Well, of course. In fact, it's quite difficult to have a real big network. Next to the normal problem we have with the software, we have the hardware issue. In fact, if you mention you are here and you want a connection with this node, each time your data flows, the speed and the throughput halves with each step, which is the limitation by the hardware, because each WLAN hardware does store and forward. It means you send the data here, and the node will save the data for some time, and then start resending it. So, but nevertheless, this is quite interesting technology because you can create a whole network without any operators or administrators doing sophisticated network stuff. Everybody can take part, and it's quite easy. So how does it look like in reality? That is a snapshot I did this morning. This is my district where I come from, Berlin. And you see the green dots are nodes, and all the red lines are the connections between these nodes. That means we created a network here. In our district, there are more districts and many more nodes in my city. And all these nodes can talk to one another. Here we have some kind of backbone connections, better locations. That's why they have so many connections.
What's the scale?
What's the scale? Well, here is a subway station, as you have here, MRT. So it's one station, and there's another station. So I can't really tell how many kilometers or something. But you can guess, I would say at least from here to here, 1 to 2 kilometers. But maybe even more, I don't know. We can find out later. No, of course not. We don't have that much open source developers. No, at least I know I'm somewhere here, so I'm a developer, and here is another developer, and all the others are just normal people. They want an access point and put it into their window or even up the roof, and just install our software, and that's it. So we have, I would say in Berlin we have about 50 core members, which means developers, administrators, or Wi-Fi experts, and I would say 500 to 2,000 just users. We can't say how many, but exactly, because there's no registration or whatsoever. But
is this only good for big cities, or will it work to help the rural areas in India or something like that?
Yes, of course. We even have connections to India and other countries where they use our technology.
The maximum distance between points?
But it largely depends your hardware and the time you're willing to spend to for a good connection, a Wi-Fi connection. So last year there was a big conference in India, a wireless conference. All these wireless people came together and explain to Indian people and Indian government how that technology works and how they can use it.
How many nodes have internet connection?
How many nodes in internet connection? Well, the point is there are several nodes who have internet connection, but as all the nodes are connected, they all have internet connection. Or do you mean how many internet gateways we have?
Yes.
Even that is hard to say. I would say in that district about 10. This district, we have, it's a bit difficult to imagine, but we have problems with internet. Our telecommunication companies are not able to offer a broadband connection in that area. And that's why so many people take part, because they get broadband connection by using our network. Yes. Yes. Yeah. You mean how can that be? That is so far. Well, ordinary VLAN technology you use in buildings is just for a few, works just a few hundreds maybe. But if you have a high point, you ask why this connection here can be, or you have other connections here going from here and even more outside of the snapshot. The point is, this, for example, is a high church. I can show you a picture later. And here is a very high building, and we have some Wi-Fi experts who spend days to optimize just the antennas and make a real direct connection. Then you can go, I would say, 4 to 5, even 15 kilometers by normal hardware. It's no problem. Well, if you're interested, I can show you. Step a bit ahead. For example, this is one of these backbone churches. It's an ordinary Christian church where we got in contact with them and we explained what we are trying to do, what we're trying to achieve, and where they were quite happy and allowed us to. They gave us access to their tower, and so in that tower we brought our technique there, and every window has now an access point and an antenna. You can see here how these connections in all the directions work. And as the churches normally are a bit higher than all the other buildings, you get over all the other buildings and can make distance connections.
So it's even better than one antenna on the very top is 8 antennas in each window is better, is that right?
Well, what's better? No, in fact, there are 4 antennas working in all directions, it means only antennas, and the 4 other ones are direct connections. That's the idea of this church. So I can show the hardware. So I think you know this kind of hardware is produced in Taiwan. But it's the most famous device we use, or the most used device, because Linksys or Cisco was forced to open source their firmware, and therefore we could alter the firmware and create our own, which is called the FIFO firmware, which you just have to install and then it works. And I can show you a picture. So it looks like this. You have a web interface, and we have default settings, and the default settings are normally largely sufficient for taking part, where you can tweak a lot, but that's not really necessary. If you want to, you can, but in fact, it's not necessary. So how does the magic work? There we use a protocol which was standardized in RFC 3626 some time ago, and they even issued a second draft, I think. In 2004 we started working with that protocol. We tried other ones before, and well, we found out that the protocol has nice features, but they don't work in the real mesh network. So what we had to do is we deactivated all the features which makes OSR, and developed our own extensions as ETX or fisheye algorithm to make it work. And all the snapshots you saw, all the nodes are using OSR today with our extensions. And that was so successful that our extensions and the OSR protocol is now the most widely used protocol in the world. There are many commercial implementations, many communities using our protocol because it's quite good. Up to now was okay. What the protocol in fact does, just to make it explain here, is in fact you switch on your node, and then your node screams out in the world, I'm here, and all the other nodes receive that message and therefore know that you are there, and then find a way to route the traffic to you and back for you. So, unfortunately, despite all our efforts, OSR has its limitations. It's overly complex by design. It's if you read the draft, it's I think about 30 pages or something. It causes a lot of traffic. There are 4 message types OSR sends to one another. And, well, all the routing information has to be calculated, which means if you have 10 nodes, one node has to calculate all the routes between and to the 9 other nodes. If you have 20 nodes, well, your calculation more than doubles, and with each node you have more and more calculation. And it has some important problem. It creates routing loops, which means that it's one of the major problems we have. Well, imagine that you are here, and we want to go to the internet here. And well, your node thinks, well, the best way to get to the internet is here, and sends data to that node. But that node thinks, well, the best way to the internet is here, and then that way up. So we'll send the data to this node. But this node thinks, well, the best way is to that node. And so the data will sweep between these 2 nodes. That's what we call a routing loop. In an idle world, the protocol will detect it and avoid such loops, but we don't live in that world. So we have problems with these loops. In fact, our network is now too big for OSR. We have about 500 nodes in the main network, which is too much to calculate for this little WRTs. They work at 100% CPU power, and we always try to make OSR slower and slower so that it can be handled by the WRTs, but it's not a solution. Therefore, 1 year ago, we sat together and we discussed the problem, and we tried to find a better solution for this routing problem. So we created Batman, which is an abbreviation, which is better approach to mobile and top networks. We tried to create a protocol which is so easy that almost everybody can understand it, which is CPU friendly. It works completely without calculation any route. And we try to create a way or a protocol which is not a way of the whole network. It's quite special, and the first time when you hear this, you get the feeling it can't work, but it does. In fact, we go back to our little here. If you see that cloud, every node knows every route to every other route all the time, which is a large problem because every node has to be informed about every routing change which takes place, and every node has to calculate the best way to all the other nodes all the time. It's quite problematic, and you don't need it because if that node says started here, well then this node decides which is the next step. So why does this node has to calculate the whole route to the final destination? So what Batman does is it just counts how many hello I'm here messages it got from its neighbors. And then it says, oh well, I got most of the messages from that neighbor, so I sent my messages to this neighbor, and then it's his problem. It's not my problem any longer. In fact, that creates a network where the routing information is distributed over the whole network. Another problem we had with OSR was that the gateway selection, as mentioned earlier, is quite problematic, the internet gateway selection. And therefore, Batman has gateway tunneling implemented, which means the traffic to the gateway is tunneled, like any VPN, VPN or something similar. And therefore, you can select your gateway, you can prevent IP spoofing, you can encrypt the traffic, whatever, you can do everything that is normal tunnel. Yeah. Even it's only a year old, we got in contact with OLPC, I think it's quite another year, because they want to use Batman as well, because it's quite CPU friendly. We got in contact with several ISPs, one Russian ISP for example, they use Batman in their internal network, and other ISPs use Batman as BGP replacement. We even have a commercial implementation, or not we, but a company from Latvia, commercial implementation. And we were asked to create an RFC of our protocol. But all this is only our first step, because this is an AS3 implementation, which means it works with IPs. Every node needs an IP, and then you can send your packages and stuff. Therefore, we started, because that Batman is working, and we started deploying it in Berlin, and I think till summer we have it everywhere running. We started working on Batman Advanced, which is even a step further. It's working on layer 2, which means you don't need an IP. You can just start your access point or whatever, and it works on the Mac hardware. And as every hardware has a MAC address, it just works out of the box. You can use other protocols on top of Batman. You can use IPv6, or you can use DHCP or IPX or whatever you want. Your network will behave like an ordinary switch. Just you put your data in and magically it comes out on the other end, but the software you run on top will not recognize how many steps were between your connection. So another big advantage is that routing itself is done by Batman, which means that before you altered the kernel routing table, you inserted routing information saying, well, that's your gateway for that and that, and that's your gateway for that and that, and then the kernel did the routing. But the kernel is a problem because the kernel is not optimized for fast switching VLAN connections. So if we can do the routing by ourselves, it will be much quicker and much more reliable the way we want it. We even plan to gather VLAN information from the hardware and integrate it in our protocol. For example, if you use a normal VLAN card and you have 3 or 4 neighbors, your VLAN card knows how good the connection to every other VLAN card is. It means maybe to him I have 6 Mbit connection, but to him I have 4 Mbit connection. So we can use that information in our protocol to provide much more reliable information about the state of the protocol. But it's still under heavy development and not stable, so it's future music. Yeah, so enough about the protocols and the ideas. I think now we should show what can be done on this. Or are there still questions? Yes?
This would vary by area, but if you had trouble in areas with regulations about the usage of the airwaves of the network, like conflict with local regulations on air,
well, we use standard hardware, which is free to use.
Okay.
So we don't have any problem with regulations and stuff.
All right.
So, okay. Then I would say we start with